We are fortunate enough to live in a world where we don't have to worry about when, where, or how we will get our next cup of drinking water. But this water does not just appear out of thin air, it has to come from somewhere. One such place is aquifers. Today we'll be discussing what exactly an aquifer is, why it has such a vital importance in our lives, and finally we will discuss the threats that we as humans pose to aquifers. So first, what exactly is an aquifer? As explained by the editors of Encyclopedia Britannica this year, an aquifer is a rock layer that contains water and releases it in appreciable amounts. The rock contains water-filled spaces that allow water to flow through it. So, in more common terms, an aquifer is an underground storage tank for water as well as a filtration system. As seen here, there are two main types of aquifers, confined and unconfined. Unconfined aquifers can be reached by any surface water simply flowing through the ground and reaching the aquifer and sitting there, while confined aquifers are covered on both the bottom and the top by impermeable layers, meaning that water cannot get in nor get out. Moving right along, aquifer recharge is the process in which water refills the porous ground. The researcher Dylan, along with his 6 counterparts who wrote the journal Managed Aquifer Recharge, Rediscovering Nature as a Leading-Edge Technology, explained the 3 main types being unintentional, unmanaged, and managed. Today, however, we will just be talking about managed aquifer recharge. This is the intentional refilling of groundwater supplies, and it is done in a way that ensures both human and environmental health while providing lots of water. In 2005, in an article written by Dylan P., he explained the different types of managed aquifer recharge, 4 of which are shown here, each type accounting for different geographical characteristics or necessities like mountains, dunes, and valleys. Now let's discuss why aquifers are so vital in our lives. According to the 2003 study by Falkenmark, Folk, Foster, and Chilton, aquifers provide around 50% of our potable drinking water. That's half of the water that we consume every day. Along with this, the same article said that groundwater and aquifers make up about 20% of the water used for irrigation. This is a huge portion of water that we depend on for both food and water. Continuing our discussion, it's important that we talk about the natural uses of aquifers. Custodio, in his 2002 study on aquifer overexploitation, addressed this significance, saying that aquifers are vital for maintaining spring discharge and river-based flow, as well as ensuring that lakes, lagoons, and wetlands stay at their desired level. Along with this, aquifers are a geotechnical factor, meaning that the water in aquifers hold together rock and soil, ensuring that there are no natural catastrophes like sinkholes. Finally, let's discuss why humans are a threat to aquifers. When pesticides and fertilizers are used to treat farmland, the chemicals become trapped in the soil and slowly dissolve into the groundwater. This is a process that can continue for decades and does terrible contamination for the groundwater, because some of these chemicals are easily degraded in the aquifer, but many of them do not degrade and instead stay there for decades to centuries. The same is true for urban development discharge. When soil and wastewater are discharged irresponsibly from urban development, the same thing happens. These chemicals seep into the aquifer and they stay there for decades to centuries as they do not dissolve easily. For example, I want you to imagine that you have a perfect crystal clear batch of blue slime that you just made, and you're playing on the playground in your hometown, and you're on the swing sets, and the slime, it just flies out of your hand and it lands 10 feet in front of you, and you are just devastated. Your heart has stopped as you run towards the slime, praying that no mulch or dirt has gotten in your crystal pristine slime, and you pick it up and your heart shatters because your slime has started to turn a brownish tint and it's speckled with dirt and mulch, and you can pick some of the pieces out, but unfortunately your slime is forever ruined because of the dirt and mulch. Aquifers, in this sense, are the slime, and contaminants and chemicals are the mulch and the dirt. You can get some of them out, but unfortunately some of it will stay there for a long time. Overexploitation is a phenomenon describing when water is pumped out of aquifers at a rate that is much higher than the rate that natural or managed recharge occurs. Outcomes include sinkholes because there is no more water to hold together the soil and the rock, water quality deterioration as more pollutants can reach the aquifer and damage the overall quality of the water, and as well as increased abstraction costs because a well has to be dug deeper and deeper to find that constant water source. One way to measure overexploitation is through the groundwater footprint. This describes the area that would be needed to sustain the current groundwater use and groundwater-dependent ecosystem services. Currently, it's calculated that the footprint is 3.5 times the actual size of aquifers, and this is just driven by a couple heavily overexploited aquifers in the countries and regions of the United States, China, Mexico, and the Middle East. This is shown on the map here by the red, orange, and tannish spots. This being said, it's important that we protect our aquifers if we have a hope of relying on them in the future. The governing bodies of the regions that I just mentioned have a unique opportunity to lead the way and set an example for what responsible groundwater protection and use looks like. We have learned about the workings of an aquifer, their purpose, and the threats that we pose to them if we are not responsible users. By protecting the groundwater resources that we have, we could be prolonging this time in which we do not worry about how, when, or where we get our water.